Okay, this is the 4.1 to 4.7 quiz for physics. Uh, it's very similar to the AMS quiz. I will be uploading the top questions and grid questions later on today, inshallah before 7. Uh, if not before 7, then before 8. بس المهم uh, yeah, I advise you to watch the grid questions and course revisions because they will probably come in the written like how the geometry written came. بس المهم, let's start. Uh, which we have a triangular lamina and we're rotating about vertex A. We're saying which ones can produce a turning effect. Okay, uh, F1 obviously can't because the line of action for F1 coincides with the vertex, so obviously F1 won't rotate. F2, does it coincide? No, it doesn't, so it will rotate. F3, does it coincide? No, so it will rotate. F4, does it coincide? Yes, it does. So it won't rotate. F5 it will not coincide. فit will rotate. فكلهم except all of them except F1 and F4. If I'm not wrong, this came in the AMS. Let me just get the answer for it. The answer in the AMS was F1, F2, and F4. Yeah, F1, F2, F4. Okay, a force F is applied to a plank that can rotate about fulcrum A. So again, we're going around the vertex A over here. The moment of force F is directed out or in. How do we know if it's directed out or in? You have to know whether it's clockwise or anti-clockwise. Remember the technique I taught you was draw it. This would be one path, and the other path would be this. Okay. Uh, So you have to check which one is the shorter path. Obviously, it's going to be the black path, which is the shorter path, and the black path is going like this. And this is counterclockwise, which is positive, because you guys know counterclockwise is positive. And counterclockwise is always outwards. If you remember from the AMS recording, clockwise is inwards, okay? And counterclockwise, I'll put CC, is outwards, okay? That's you have to know this. This question, it was also in the AMS. I think كلهم يعني all of these were in the AMS. Uh, Again, a force of magnitude 40 newtons is exerted on the square lamina of sides 2 centimeters. This force creates a moment of negative 40 about point A. If it's negative 40, what does that mean? It means it's clockwise. Why clockwise? Because it's negative. We said clockwise and it's negative. So we have to check which rotations here are going to be clockwise to give us the negative 40. So we have to test out each point. To start with Q, obviously, about vertex A, huh? We're saying about point A. So over here. To start up Q, obviously the force Q coincides with A, but we won't be taking Q into consideration. Let's start with P. P can rotate like this, or it can rotate like this. Obviously, it's going to rotate this way, which is the short path, and that's counterclockwise, so it's positive. Okay, if you want, if you're confused because I did one color, P can rotate like this, or it can rotate like this, the long path. Okay, obviously it's going to take the black path, and the black path is counterclockwise, so it's going to be positive. Okay, so will it be P? Obviously not. Now let's try R. R can either go like this, or can either go like this, or it can go like this. So obviously you're going to take the red path, which again is counterclockwise, which is positive. Okay, so it won't be R. How about S? S can go like this, or it can go all the way around the square. Obviously it's going to take the red path, and the red path is like this, which is clockwise, which is negative. So S is correct. What about S? Again, S, again, same thing. Uh, it can either, sorry, but what about T? We said S is correct. T can go like this, or it can go the other way. This is easy, so I'm just gonna draw it in case you guys don't understand. Obviously, it's gonna take the black path, and the black path is going like this, which is clockwise, which is negative. Okay, المهم, T and S are correct because they both produce a clockwise rotation. Okay, ABCD is a rectangle of sides 10 centimeters, 12 centimeters, whatever. Uh, F1 is 8 newtons, F2 is 10 newtons, and F3 is 4 newtons. They want the net moment. Okay, the moment, net moment, m net equals to the moment of force 1 plus the moment of force 2 plus the moment of force 3. It's the net moment, so you add them all up. Let's start. F1. What's the moment of F1? If you remember, the moment is equal to F times d perpendicular. Okay? This is d perpendicular. Okay? F times d perpendicular, if يعني I show you, if this is a bar and I put the force like this is the force. Okay, and I gave you two distances. I gave you this 5 and I gave you this is 4. Okay, and I'll tell you the force is 10 newtons. What will the moment be? The moment will be 10 times d perpendicular. In this case, which is d perpendicular, is going to be the one that makes a right angle. Okay, the right angle because it's perpendicular, which is 4. So you get 40. That's how you find d perpendicular. You don't take 5. 5 is just d, but you need d perpendicular, the one that makes a right angle. المهم, the moment of F1 will be the force of will be sorry, it's plus minus F times d perpendicular. My bad. It's always plus minus F d perpendicular. Why? Because it could be clockwise, it could be counterclockwise. Let's look at F1. Will it be أول شيء you have to check if it's clockwise or counterclockwise. F1, take it to A that way, and you can also take it this way. Obviously, it's going to take the black path, and the black path is going like this, which is counterclockwise, so it's going to be positive. So F1 will be plus. How much is F1? F1 is 8 newtons. Okay, so plus 8 times, this is times, d perpendicular. The distance d perpendicular between A and F1, obviously you don't connect them, right? You need the right angle. So you have to draw the line of action of F1, which is already drawn, and you have to check the distance from A to that line of action. It will be this distance. If the whole thing is 12, obviously this is half of 12, which is 6. So d perpendicular is 6. So it's 48. Let's do the rest quicker now. F2, let's look at F2. F2, you have to know if it's plus or minus. Draw the line of action of F2. Does it coincide with A? Yes, it does. So we skip F2. Okay, we skip F2. F2 is 0 because it coincides with the line of action. So it coincides with the turning point, with the torque. F3, let's check F3. F3 doesn't coincide, obviously. Okay, you have to check if it's clockwise or counterclockwise. Okay, you take F3 like this, or you take F3 like this. Okay, obviously it's going to take the red path, and the red path is clockwise, which is negative. So it's going to be minus the force F3, which is 4 newtons, times d perpendicular. So you have to check it. You have to check the distance between A and the line of action of F3. So take the line of action of F3 and take A to that line of action. It makes a right angle over here. And what's this distance over here? If the whole thing is 10, this distance is half of that, which is 5. So minus 4 times 5 equals minus 20. Then what's the total net? You add 48 and 0 and minus 20, and you get 28 Newton centimeter. Okay. Question 5. Uh, the moment F1 about the fulcrum is directed into, and it's negative. Okay, into auto, we know that that's when they're asking whether it's clockwise or counterclockwise. Let's look at F1. F1 into the fulcrum is like this, or it's going to be like this. Obviously, it's going to take the red path, right? It's going to take the red path, which is like this. Okay, and that means it's counterclockwise, which is negative, right? But since it's counterclockwise, it's clockwise, not counterclockwise. That means it's clockwise, which is negative. Uh, so since it's clockwise, will it be into or out? We said if it's clockwise, then it's going to be in. How about F2? Let's look at F2. And since it's clockwise, we put negative on. And also we put into since it's clockwise. Whenever you see clockwise, you put into. If it's counterclockwise, you put out. F2 can go like this or can go like this. Obviously, it's going to take the red path. It's shorter, and you can see. Which is like this, which is positive, which is counterclockwise. And since it's counterclockwise, we always say out, outwards. Counterclockwise is always outwards. So we put out of the plane of picture, and it's positive by convention because it's counterclockwise, it's positive. Number 6, a person is pushing a box across a horizontal floor. The box gets stuck at the door stepper over here. Which of the forces will produce a clockwise moment on it? Okay, the options here were weight, normal reaction, I think friction and the door stepper, the door stepper, or something like this. المهم, let's start canceling out. The normal reaction is upwards, and the weight is downwards. The friction is like this, F. Oh no, it wasn't door stepper, it was the push. I think it was the push of man. Okay, and the push of man is obviously like this, right? This is the push. Let's look at what we have. We're rotating obviously about the door stepper, right? Let's look at the forces. أول شيء, the line of action of friction coincides with the door stepper, right? So we cancel out friction. And the line of action of the push, if you see, it's on the same line as the door stepper. So we cancel out the push. So let's clean it up. We're gonna be left with the normal reaction and the weight. Okay. Now you have to see. You have this over here. Which one will produce a clockwise moment? You have to check both. Let's start with the normal reaction. Normal reaction can go like this, or it can go all the way around like this. Okay, which one's gonna choose? It's gonna choose the black one, and the black one goes like this, which is positive, which is counterclockwise. So will it be the normal reaction? No, it will not be the normal reaction. So that means it will be the weight. And to prove it, let's just draw it, just so you can understand. This is the weight. It can go like this, or it can go all the way around like this. Obviously, it's gonna take the black route, and the black is going, the black path, sorry, is going like this. Okay, and this is clockwise, which is negative. Okay, it's clockwise, the weight. And what is the sign of clockwise? Negative. This is easy. Seven, question 7. You have to find the torque of each force. Torque the moment. Okay, and this was a question actually. What defines the turning point of a force? It's actually moment, or if there's no moment, you put torque. It came in the AMS. Okay, the torque of F1 about A, we have A, right? We want F1. Where is F1? F1 is over. Oh, that's not A. Sorry. A is over here. I put it in red. A is over here, and they're asking about F1. F1 goes like this, right? And the line of action of F1 traces back and coincides with A. So what does that mean? F1 will be cancelled out since it coincides with your point of rotation. F2, we have A over here. We have F2 over here. How do you find the moment of F2? The moment of F2 equals plus minus the force times the perpendicular. Plus minus. Let's see, is F2 clockwise or counterclockwise? F2 can go like this, or it can go all the way around. Like, let's take this blue. It can go all the way around. Okay, obviously it's gonna take the red path, which is clockwise. It's clockwise, right? This is clockwise, which is negative. So it's gonna be negative the force F2, which is over here in the question, 20, negative 20. So I put an arrow. Negative 20 times d perpendicular. How much will d perpendicular be? Obviously, it won't be 10. You have to trace the line of action of F2 and trace the line of action of A. See, where is it perpendicular? It's perpendicular over here. And that distance is 6 meters. For negative 20 times 6, and you'll get minus 120. How about F3? The torque of F3, the moment of F3 equals again plus minus F3 times the perpendicular. Let's check F3. The moment of F3 will be plus or minus. F3 is over here. It can go like this, or it can go all the way around like this. Obviously, it's going to take the red path, which goes like this, which is positive, which is counterclockwise. So it will be plus F3, which is 6 newtons, times the d perpendicular. Let's look at the d perpendicular. This is the line of action of F3. This is the line of action of A. Where are they perpendicular? They form a right angle over here. And what's this distance? You have 10 and you have 2. So it will be times 12, which is 72. So minus 120, we got it. 0, we got it. 72, we got it. What will the net torque be? You just add them all up, right? Add for the net moment. Okay, just put minus 120 plus 72. You get 48. Okay, question 8. Okay, for part A, these two forces are what we call a couple of forces. Okay, couple meaning two forces acting in opposite directions, and they're parallel. They're not coincident. Okay, please remember that sentence. A couple of forces are two forces acting in parallel in opposite directions that are parallel and not coincident. Okay, because this was an ILS question. Uh, المهم, to find the moment of a couple, it's always FD. F times the distance. The force, these are always the same force. Always. To be a couple, they have to be the same magnitude of force. The distance isn't the perpendicular, it's the distance between these two. Okay, that's it. So in this case, what's the moment created by the couple of forces? It's gonna be F times D. What's the distance between them? It's gonna be an inner radius of 10 centimeters. So this radius here is 10. Okay, and the outer radius of 15. So like this is 15. The whole thing is 15. المهم انت what you need to know is the outer radius. That's what matters. If the outer radius of the bigger circle is 15, yeah, this is 15, so then the diameter will be 30. So it will be the force, which is 200 times 30 centimeters. They want it in meters. For what you do, you have to convert it to meters. How do you change this 30 centimeters to meters? You divide by 100, you get 0.3. The 0.3. So 200 times 0.3, you get 60. That's it. Then the force F, so they want to add two more forces, okay, in the inner radius, in the smaller circle. Okay, they want those two forces to cancel it out, so the net moment on the spool is zero. The force F on A must be leftwards, and the force B on B must be rightwards. So let's look at the force on A. Okay, if you put the force on A to the right, then it's going to be adding more moment, and that wouldn't cancel it out and give it zero. So you have to put it to the left, right? So you put the force to the left because it's going to be cancelling out this to the right. Obviously, the magnitude of this force that's closer to the circle will be bigger, and that's for part C. We'll find the magnitude. Part for the force on B obviously is going to be to the right because it has to cancel out this 200 Newton. Okay, that's how you do it. For the one on A will be to the left, and the one on B will be to the right. Okay, and then the magnitude of F is how many newtons? 300 newtons. Let me show you. We know that since it's a couple of forces, the couple of forces will be F times D. And since we want them to cancel it out to become zero, that means this F times D should be equal to the 60. Why 60? Because يعني it's the same height, it's the same magnitude. Same magnitude as the other couple because we want it to cancel out. This F times D equals 60. The force, we don't know it. We're trying to find the magnitude of these couple of forces. The distance. So we said it's like this and it's like this. What's the distance between them? They said the inner circle, the radius is 10. For what will the diameter be? 20. Okay, the diameter being the distance. So F times 20 centimeters equals 60. Bear in mind it's 20 centimeters. We need it to be meters. So we divide by 100. So it will be F times 0.2 equals 60. How do you find F? You divide by 0.2. You'll get F equals 60 divided by 0.2, which is 300. That's it. يعني. See, 300. Question. How many questions are? 10. طيب. What's the moment of this couple? Again, to find the moment of a couple, it's just FD. Okay, the force in this case is 15 times the distance, which is 2 centimeters. You need it to be meters, so you divide it by 100. So you do 15 times 0.02 and you get 0.3. Yeah, you get 0.3. Question 10. Yeah, these are very easy. What is the magnitude of the moment F about vertex A? Okay, uh, in this case, when it's one force and they're asking for the magnitude, there's no need to do plus minus F times D perpendicular because they're talking about magnitude. So there's no need to specify the rotation, whether it's clockwise or counterclockwise. So you just do FD perpendicular. In this case, it's 20 newtons as the force, so it's going to be 20 times D perpendicular. D perpendicular, you draw the line of action of the force. We're talking about vertex A. And then you draw the line of action of A. It's perpendicular over here. And this distance is 60 centimeters. They need to be in meters. For 20 times 60 centimeters, it becomes 20 times 0.6 meters, which is 12 Newton meter. Okay, please make sure to put the units in your exam tomorrow. It's very important, and I can't stress on how important the units are. Before moving on, and before ending the recording, there was one question. that came in the شو اسمه CA this week. They gave a car, and there was two blanks. There was one here and one here. They said net moment. Oh no, it was the other way around. Small blank, big blank. There was a blank here and there was a blank here. Okay, and they said the net moment. They said the net moment. What will it be? The answer was 23 and clockwise. Okay, why? Honestly, I don't know. It was a stupid question to be honest, but يعني the answer was 23 and clockwise. Because into when you solve, you get minus 23 as your net, and minus 23 is 23 newtons in the clockwise direction. Okay, this is يعني in case it comes typing again. I thought I'd let you know. There was also one question. These are just يعني what I saw people get wrong this week. They gave a box and they gave a few forces F1, F1 over here. This is uh, no, it was on the left, I think. It was over here. This is the center of rotation, so like A or something. There was a force here, F1. There was a force here, F2. There was a force here, F3. And then there was a force here, F4. Okay. And then they asked which is most effective. Okay, the most effective force is always the one that's furthest away from the axis of rotation. So in this case, it will be F4. This game, other than that, يعني, and I'm looking at the answers now. Uh, there's nothing. There was one. It came like the AMS question. It was a force 10, and there was the distance to the center of rotation was 0.3 meters. They asked for the moment. Okay, the moment was negative 3 newtons meters, because أول شيء it's clockwise, it's moving like this, right? So it's negative. وتاني شيء they a lot of people they put, and I saw them, they put 3. They didn't put negative 3, and they told me after the exam, طب وليد, didn't they say magnitude? No. Okay. يعني please pay attention to the question. Haram you lose a mark of يعني a silly mistake, especially now periodic. You can't fix your mistakes. You put it, you get it wrong. ف make sure to read the question. If they say magnitude, keep it positive. If they don't say magnitude, put the negative sign. Haram you get it wrong. The turning effect is the torque. Uh, I think, yeah, there was a question. It showed you pictures, and you had to put yes, 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 no. I think, and if I'm not wrong, they showed you pictures. Well, was it pictures? No, they said يعني stuff. And I have the book here, and I'll show you where it shows. ف I'll tell you. I think the answers were pushing a door, obviously. Uh, the car wheel, fixing the car wheel was also one. I think one of them was I forgot the last one. But يعني a lot of people يعني surprisingly got this wrong. I think I remember somebody telling me, why does it have torque? أنا صراحة I was confused. How come? Obviously, a door, when you push it, you have the hinges over here of the door, and then you have the door over here, right? When you push it, it's rotating around this hinge. So يعني I got surprised. People got this wrong. For the answer for that one, I don't know if it was pictures. I really forgot. It was yes, 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 and no. Okay, that's it. Okay, I think that's it. And I just went over the paper for last week's AMS. There's nothing. Maybe some people they got optics, but optics isn't included. That's it. Thank you for watching. I'll upload the course revision tonight, inshallah. Bye.